In this lecture, we are going to see about basic global mesh settings that are present inside Ansys software. And the Ansys version software that I am using here is Ansys 2020 R1, which is the latest version of Ansys software. For this particular purpose, I've already opened the Ansys Workbench software. I have dragged and dropped the static structure onto the project schematic. And I already imported this particular geometry file that I have provided to you in the resources tab into the design modeler. And now I also opened this Ansys mechanical module where we are going to do the meshing. So here we are in the Ansys mechanical module, and now you will be able to see I have a simple cube with a circular hole in between. So first thing is whenever you load a geometry into Ansys Workbench, the first thing you are going to do is you are going to generate a mesh with the default settings, and once you generate that particular thing, then based on the mesh that has been generated, you can modify it through by using some advanced global options as well as the local options. So in order to generate the default mesh, you need to click on the mesh option here in the model tree, and you need to right click and say generate mesh, or otherwise you can click on this particular tree group, and you can also go to the mesh tab here, and in the mesh tab you can click generate to generate the mesh with the default settings. So in the default settings, three things you need to take care about. One is known as the physics preference. So physics preference is nothing but so for example, let us say you are creating this geometry and you are going to mesh this geometry to perform, let us say, linear static analysis. So for that purpose you need to select this mechanical solution as the physics preference. Otherwise, let us say you are creating this geometry, meshing this geometry for performing CFD analysis on it, you need to select the CFD as the physics preference. And once you select CFD as the physics preference, here we have three types of solvers for CFD inside Ansys. They are nothing but the Ansys Fluent, CFX and Polyflow. Anyway, we are not going to do any CFD problems here in this course. We are mostly concerned with the linear static analysis and thermal analysis. So for that purpose, you can always prefer mechanical, and by the way, this mechanical option is the default. So what it will do is, based on the type of physics you select, it will change some settings that are already available for generating the default mesh. So you will get different types of meshes for different physics preferences. So based on your type of analysis, you will be selecting. Let us say in structural only you are going to do something non-linear, or let us say in thermal analysis you are going to perform non-linear analysis. You will be selecting, instead of normal mechanical, you will be selecting some non-linear mechanical, which will change the default settings as I told you. So for now, for all of our purposes, we will be taking only mechanical. Okay. Then the next thing you need to know is the element order. There are two types of ordered elements. One is the linear order element and the quadratic order element. Simply, linear order element means an element which doesn't have a mid-side node. Quadratic element means an element which is having the mid-side node. So you can go out and check the theory on mid-side node elements and non-mid-side node elements, and what is the difference between these two elements. Let us say you have two nodes and these two nodes are connected by an element. So this is nothing but a linear element. But what will happen in the quadratic element, you will have two nodes and they are attached by an element, and in between those two nodes an extra third node will be placed at the exact middle element side, which is known as a mid-side node. You can go out and check more about mid-side nodes and other things. Generally, for our purpose, let us say in industry purpose, if you are using hexahedral mesh, you have to select linear. You can select linear, but if you are using tetrahedral mesh, you have to go for the quadratic type. So based on what type of element you are using, you need to choose this particular thing, or otherwise you can also leave it to program controlled, and based on the method we are going to prescribe to this software, it is going to anyway choose whether it will be taking a linear or quadratic element. And remember, by default, if we set the physics preference to mechanical and if we set the element order to program control, it will generate a mesh with the tetrahedrons, and that to quadratic order. Element order is quadratic. Okay, but if you generate hexahedral mesh, by default it will generate quadratic model, which we don't require. So for our purpose, remember only one thing: if you are using tetrahedral elements, you have to use the quadratic element order. But let us say you are generating a hexahedral mesh, then obviously choose the linear one, as it was found that there was no much difference between the accuracy of solution between the linear and quadratic hexahedral elements, and anyway the time of solution for quadratic hexahedral elements is much long when compared to the linear hexahedral elements. That is why it is commonly followed in the industry. For now I am going to just select program controlled, and what I will do is I will right click on this mesh option, and I am going to right click and say generate mesh. So I will be able to see a mesh which is generated with the default settings, and here we got some default settings. Then the next thing you need to know is the element size. So if you want to control the element size manually instead of the automatic measure, you can enter whatever the default element size you need. See this, there is an algorithm which is called as some box diagonal algorithm, that dictates based on the geometry given, based on the physics preference, based on all the options that we have selected, it will determine what will be the default element size. And remember, if you change the geometry, if you change any setting, it will be definitely changing. The default element size will be changing. Instead of let us say the computer selecting the element size, default element size, you want to give some manual sizing, you can give it. So for example, let us say I want to give an element size of, let us say 10 mm. So I am going to click on 10. So what will happen is, every element that is going to be created here, it will have an element side length of 10 mm. See, once you have changed this particular element size option, what happens here in the mesh branch, what it is showing? It is showing a thunderbolt mark, which means we have to update the mesh. And here also you will be able to see a pink color mesh. Pink color mesh denotes means the mesh has to be updated, or otherwise the mesh that you are seeing here on this object is belonging to the settings which you have previously used, but now you have changed this particular setting, so you have to update the mesh. That is what it is denoting. So what I am going to do is I am going to just right click and say generate mesh. And see, once I generate the mesh, as I have increased the element size, you will be able to visually see that the particular element density has decreased. So if you want element density to increase, element density means nothing but how many number of elements are being fit in a particular geometry. If you want to increase the element density, what you are going to do is you are just going to decrease the element side length or element edge length. So let us say I will keep on I will be typing some 2, and you will be able to visually see that the density of this mesh will increase. So I will go here and right click and say generate mesh, and yeah, it is finished, and you will be able to clearly see that the mesh density has increased. So this point is, if you are decreasing the element side length or edge length, or you are decreasing the element size, you will have more mesh density. Likewise, if you are increasing the element size, you will have less density in the given object. This object is a very simple object. We are able to get hexahedral meshing, but remember, creating hexahedral meshing, that too with automatic algorithms, is very difficult for real world problems. And the next thing you need to check out in this is the option called resolution. So previously in previous software, we used to have something called as a relevance center, where we could select 3 settings: coarse, fine, as well as medium, and in that also we can give a value change between -100 to 100. So previously, before 19.2 version, we used to have that option, but that particular option has been gone from 19.2 onwards. If you want to increase the mesh density, you need to increase this resolution value, which by default is 2, and if you want to decrease the mesh density, you need to decrease this particular resolution. Right now what we are going to do is we are going to increase this resolution settings, and remember this resolution settings can change from 0 to 7, where 0 is the coarsest mesh you can get with the settings that you have, and 7 is the finest mesh which you can get with the existing settings, and anyway by default it will be having a value of 2 resolution. And see, for now what I am going to do is I am going to just scroll down, and here in the statistics I will expand the statistics tab, and here if you observe how many number of elements have been created, there are about 13,598. okay, so 13,598 elements were created and some 61,561 nodes. Now what I will be doing is I will be scrolling up, and in the sizing options I will be increasing the resolution. That means I'm going to increase the mesh density. That means number of elements are being increased, and as well as number of nodes also will be increased. Let us say I will set it to 7, which is the highest level. So I will just right click and say generate mesh. You can also click on update mesh, because already once you have generated the mesh, you can click on update mesh, and you will be able to see here that we got a mesh that is different from the previous one. Now I will be just checking out how many number of elements and nodes have been created. So here whatever the settings we had made, that hadn't changed this particular nodes and other things, but what we'll do is, because why this happened, because we have changed the element size, default element size we have changed, so that is why there is no much effect of resolution on this particular problem. So what we are going to do is I am going to just type in 0, which will reset the value of the element size to default, or let us say automatically calculated by the software. Now I will also set this resolution to default, that is by typing in -1. Then what I will do is first I will generate a mesh, and then we will see some statistics, and then we will again increase the resolution, and we will see the effect on the geometry. Now it is completed, mesh is completed, and here you are able to see that we got somewhere around 1404 elements with 7334 nodes. Now what I will do is I will go here, I will change this to 7, which is the highest setting, and as obviously if we increase the resolution, we need to have a more mesh density, that means more number of elements and more number of nodes. So I'm going to generate the mesh, and let it complete. It will take a little bit of time, so don't worry. Yeah, meshing is done. Now you can visually see that as we increase the resolution, what happened, the mesh density has increased drastically. And here also if you scroll down and come to the statistics tab, you can see there are 1,43,724 elements have been created. Previously how many number of elements are there? See, previously it was around 1404, like more than 100 times increase happened in the number of elements as well as number of nodes also. Like, okay, so if you just change the resolution to 0 means it is the coarsest mesh you can get. You just update the mesh, and you can see both visually as well as quantitatively that the number of elements that are generated if we decrease the resolution are changing. Here you can visually check out that the mesh density has decreased very drastically. So if I just scroll down and see here how many number of elements, just simply 1 or 2 elements. So remember this thing, resolution is the option which you need to change in order to either get a coarse mesh or fine mesh with whatever the default settings that you are having. And remember one more thing, if you change anything from default, this resolution option might not work. And if you want to set this resolution option to default, you can just type in -1 and press enter, or otherwise anyway we know for Ansys mechanical the resolution option will be 2. You can just directly type in 2 and press enter. That will also be good for you. Once I am done with the settings, I am going to just update the mesh. Anyway, I told you we can also update the mesh. Once we have generated the mesh, we can directly update the mesh. And in the next lecture we are going to see how to use some localized mesh sizing options, body and other geometrical sizing options inside Ansys Workbench software. Thank you.